Hello there everyone, welcome to the webinar on network transformation in large-scale enterprise networks. My name's Malcolm Boudin and I'm the Technical Director at MNB Networks, and today we will be running through some areas of network transformation, some of the considerations that you should have in large-scale networks and how this can impact the success of your project. So before we jump in, just an introduction to MNB Networks. We're a network consulting organisation based in Scotland in the UK, and we work with organisations across the globe on all areas of network engineering, design, network automation across LAN, WAN, security, wireless, data centre and voice technologies. Some of the services we offer are on the screen, and we'll now just proceed with the webinar. So the agenda for today, we'll cover the topics, and it's more of a conversational seminar where we'll explain some of the challenges with legacy networks, especially at the global or large enterprise scale, how to plan to move towards a modern network. And a modern network, we're talking about all the things that you're probably used to hearing about, like software-defined networking, automation, SD-WAN, data center, cloud, that type of thing. Which takes us on to data center and private and public cloud, along with WAN and SD-WAN, which fall under the same bracket, and then local area networks and Wi-Fi. So the areas for network transformation, there's a lot, right? Especially in the global scale, and the complexity is not always around intricate little problems that you need to solve. It's normally to do with the scale and the challenges that come with the scale of a large global enterprise. So the first thing to clear up is it can be overwhelming and it can be difficult to know where to start when you're approaching a network transformation. And the reason for that is that we have quite a few areas that we need to actually cover. So I've mentioned some of those already, but you know, buzzwords, SD-WAN, IT/OT convergence, and a lot of these things that you see on the screen, cloud connectivity, all that kind of thing, you can look at them in isolation, but what you actually really have to do is you have to look at them from an end-to-end architecture perspective. Some of the challenges that we see when we work with customers on network transformations are that they don't actually have a good handle on what they have in the network, and that relates to, you know, network discovery has to be part, and then monitoring systems help with baselining the network and how it's actually operating today before you move to the new infrastructure. So yeah, I thought the picture there would maybe resonate with people as to how you might be feeling at times when you're working on a network transformation project. So when we start going into like what some of the challenges are in a little bit more detail, and these are very common across different enterprise networks that we've worked on, where there's limited to no documentation or tools to obtain documentation. We also see a lot of the time where there's design decisions or implementation decisions made at like a local site or within a country, but if there's many countries and different regions, then this can result in a lack of standardized design and configurations on the existing network that you're about to transform into a newer infrastructure. So that this isn't just a result of people not looking after the network, it's normally a result in large-scale networks, a result of growth through acquisition, mergers, divestitures, carve-outs. These types of things can you can inherit technologies that maybe are not in your portfolio of preferred technologies. We also have like multiple teams throughout that have to collaborate for a network transformation, right? When we do a network transformation, it's never just the network team. We have to liaise with server application teams, identity, cybersecurity, DNS, all these different hosting teams and all this. And there's a lot to plan, and that can sometimes cause probably a little bit of politics, and then also some challenges in regards to making sure that everybody's aligned. But it is definitely a challenge. And then we also have to consider technology interoperability. So we don't just have to, like, for example, connect a checkpoint firewall to a Fortinet firewall and see if we can get them to sing together, or a Cisco switch to a Juniper router, or an SD-WAN appliance to a non-SD-WAN via BGP. You know, we need to test this at scale. So if we do it in one data center, we might need to do it in 9 data centers, and we need to make sure that that's actually going to work as we move through the design, and hopefully we can then develop like a standardized, repeatable process for a lot of the stuff that we're going to be doing in a network transformation. But these are definitely challenges that we see as recurring through multiple different customer networks. So the next question is, what does a modern large-scale enterprise network actually look like? And there's an example here where we have a picture of quite a complex network on the right-hand side. And what I would say about large-scale enterprise networks is that we really do need to, you know, approach them with care, and not, we're way past the days where networking is just seen as plumbing. Even if you just look just at this diagram, you can see that there's a multitude of technologies where we have a cloud layer up the top, we have a data center down here, and then multiple different site types. We also have different transport types like internet connectivity, MPLS connectivity. MPLS is not dead. It's definitely not dead, even though you might see it a lot on the, you know, on the marketing side of things with some of the vendors. MPLS, layer 3 VPN, layer 2 VPN, Ethernet, these types of things are still used actively. But in general terms, in the modern large-scale enterprise networks, we are seeing more of an internet-first strategy, an internet-first connectivity strategy, where it's actually internet-first, cloud-first. So that sort of catchphrase comes from the perspective of, we have internet for our transport links on our sites, and then we're looking to move our application servers to infrastructure as a service in Microsoft Azure or GCP or Amazon Web Services or Oracle or something like that. We're seeing SD-WAN become more prevalent in the industry. It's been around probably since 2015, the SD-WAN, and it does operate quite differently, even though it's just a WAN to get from site to site. In many people's eyes, it is quite different. So we do also still have traditional WAN connectivity types, as I mentioned before. So the approach that most customers that we're dealing with are going with are hybrid cloud. So they have some stuff in their Azure or AWS or whatever, but they're also retaining a co-location data center facility to host some of their stuff, and then they're creating like a hybrid cloud environment. So some of those customers who are large scale, they're actually building a private cloud. So they're doing things like building like compute platforms in the data center just to host network infrastructure, so that can be all network infrastructure can be virtualized, or most of the network infrastructure such as firewalls and routers and things like that can be virtualized. And then that is completely separate from application hosting. Application virtualization has been a thing for a long time, storage and compute for application hosting, but it's now coming into the network space, and the whole idea with that is to have orchestration platforms which can automate a lot of the provisioning, maintenance, monitoring, and all that of the network. So private and public cloud, everything is not moving to the cloud. It's moving to either public or private cloud. So we have the remote access solutions, which some of you might have heard of, secure access services, edge, and then also traditional VPN platforms. So here we have, your traditional IPsec VPN user that might authenticate to this hosted service, or they might authenticate to something legacy in a legacy data center over here. We also still need to think about like URL filtering, which can be delivered with an on-prem solution or a secure access services edge solution, which we would probably need to go into a deep dive as to what those are in more details. So that's a sort of like an overview as to what most companies are trying to get towards. If we focus in now on like a legacy data center and what we're typically moving away from, it would be on the left hand side we have effectively a big pair of switches. So if you think traditionally, these are things like Cisco 6500s, Cisco Nexus 7000 servers, with an access layer in the data center, and then servers dual homed to these access layer servers, and there might be a firewall and then a wide area network. The things then moved along slightly where we started seeing like more modularized networks. And if I zoom into this one a little bit on the right hand side, it's a similar sort of structure where you can see core switches and then top of rack switches in the red lines there, and then multiple tiers of firewalls, DMZs to protect web-facing servers on the top pair of firewalls, and connectivity to the internet, in addition to wide area network connectivity to different regions and different places in the network. So these are pretty much where a lot of organizations currently are, and what they're moving towards is more of something that looks like you see on the screen. So this is a data center network more aligned to a software-defined data center. And to summarize what that means is that we typically have spine and leaf topology. As you see, this is illustrative of data center 1 and data center 2. We have a spine and leaf topology, but then we typically have a management controller or a management platform that is in control effectively of these data center hosting infrastructures. So this would be your private cloud. And you can see there that we have servers, load balancers, firewalls, out-of-band management, these types of things that will be hosted on these private cloud platforms. But then if we also look where you see the data center 1 spine nodes connecting to the data center 1 core switches, and then everything upstream, it looks more like a traditional data center. Where organizations are going when they build these sort of spine leaf fabrics for on-prem, they have to come out of the spine leaf fabric, connect to core switching or WAN infrastructure upstream. And if you see, we have a load of different clouds at different levels of the infrastructure, which illustrate anything from, they could be a legacy data center you see there in the middle, second cloud from the bottom. This might be if you're in a migration scenario. We have public service WANs, so these could be cloud providers like Azure, AWS, Oracle that I mentioned earlier, or they could be, if it's a public sector client, it might be a public sector network, for example. And then, of course, up the top we have the internet as well. So I suppose from this slide's perspective, in addition, we also have, you know, the various different traditional things like load balancers, DNS load balancers, web proxies, these types of things that we have to still integrate all this together. So the next thing to note about this, I probably should have put this bullet point up first, but typically multiple data centers in going back on topic to an enterprise, large scale enterprise. If you think global enterprise or multiple regions, if you look at this topology and we zoom in on it again, this illustrates 2 data centers, right? In a large scale global enterprise, you probably have at least 10 of these data centers which are connected to, you know, via a high speed backbone through one of the, you know, the global service providers like Equinix or something like that. But in addition to that, you will also find that in each data center, typically you'll have some kind of interconnect, perhaps not from exactly here, but interconnects to like a cloud service provider there. And then, you know, the same sort of thing here, where although you've built your own infrastructure, it's likely that in large scale global enterprises, they're also connected to their preferred public cloud provider as well. So then you can see how the complexity really starts stacking up when, you know, when we get into this in more detail. So I'm going to speed up a bit. So I think I've explained some of the spine and leaf switching infrastructure applications, mainly virtual machine applications are these days, but there are still legacy applications that might have bare metal servers where an application is physically installed on a server and hosted in a data center. And it's these types of reasons why we still have like the hybrid approach, because we can't go and rack physical servers in a public cloud platform. So the last point on this slide is around traffic flows. With all this said and done, and multiplying what you see on the screen by 10 or thereabouts, the traffic flows of the network to the wide area network, the cloud service providers, partner networks is very complex and more complex than it's ever been. An example of this that I would like to show you is just to put it into perspective. So if we go back to the previous slide and let's say we're just focused in getting to the data center. This is one data center that we're about to talk about on the next slide. So we have our sites down here, and we have our own data center here, and then we have our Microsoft Azure instance here. The green routers or circles, but they're actually routers, are SD-WAN, and the blue routers that you see on the screen are internal routers to provide private connectivity. So that would be this connection here is private connectivity from the enterprise data center to the cloud service provider. And this is what we would multiply by however many data centers you have in the world. Typically, you'll have an interconnect in either a subset of those locations or in every location, depending on how critical cloud connectivity is to your organization. So if I remove my annotation off the screen and we talk about, you know, I think we've talked about it a little bit. Do you go public or private cloud? It depends on your organization, but large scale, it's almost certain that it will be a bit of both. The application hosting environment will be across both, and then it's really key to understand the traffic flows to and from your applications. So if I explain that in a little bit more detail, the application traffic flow that just appeared, this would be if you had a site, an edge site, that's connected to your wide area network, and you needed to access the co-location facility. So this is your own data center, like an Equinix or a service provider's data center. And you needed to access some applications, which are these servers down the bottom here, which might be VM or something along those lines. We might also need a traffic flow towards Microsoft Azure, but actually leveraging our private link into Microsoft Azure. So that's indicated by the blue line going over an express route, which is a private BGP-based connection between customers and the cloud providers. It's called slightly different things with different providers, so like direct connect and express route and these types of things, depending on the provider. But express route is Microsoft's iteration. We might need to go from the site directly to the servers in Microsoft Azure. And then we might also need server connectivity and communication from our co-location servers into Microsoft Azure. Okay, so that hopefully gives a good overview as to some of, just only really touching the iceberg on some of the data center considerations. So we'll now move to the wide area network and a similar sort of approach, right? Where, in my opinion, the wide area network is probably the most important part of your network. If you don't have a solid, well-performing wide area network, then you will not be able to access your applications because there's very little client server applications that are hosted on site now. It's all software as a service, infrastructure as a service, hosted in public clouds or hosted in a co-location or a head office. Therefore, the wide area network is imperative. So the ability to be able to, because of that, I should say, you really need the ability to measure the application performance. It's really, really important. And the WAN strategy is definitely based on, you know, where you put your applications is going to drive your WAN strategy. SD-WAN, as mentioned before, is becoming more prevalent, and it has some of this application performance monitoring that we talked about a little minute ago. One thing that I would suggest, it's not, SD-WAN is completely different to what you're used to. Yes, it achieves the same thing, but the way that SD-WAN operates using underlays and overlays, and we route traffic in an underlay, which is like your native transport, like internet link, MPLS, layer 3 VPN, Ethernet links, these types of things. You might still route some traffic natively in those, but you're also going to route traffic over the top in the overlay. So, and then this is an important here, right? That sort of reiterates that point. If you've got different sites with different underlays that have different SLA requirements, then you're going to get different network routing behavior. Right, so if we focus on the SLA part, let's say we had a site that that was suffering a performance issue. Like here's one I prepared earlier. So if you can't see that, you know, we've got some sort of monitor going to 8.8.8.8, which is the Google DNS servers as a measurement probe. With SD-WAN, this is where we get some visibility. If we have some sort of like performance SLA measurement, and if we look at this diagram here, we have multiple different paths. So we've got 3 different transports: transport 1, transport 2, and transport 3. So this basically means, but we have one overlay, like, so it looks like one network, even though we might be using MPLS on one link, layer 3 VPN, MPLS on one link, layer 2 on another link, and internet on another link. So you can see how the SD-WAN, if we've got 3 services at the top, that, you know, we prefer different links depending on the application. So service 1, we want the traffic to come over transport 1. in red, then transport 2 in blue, and then transport 3 in green. In service 2 in the middle, we want by default the traffic to come over transport 2 in blue, then transport 1 in red, and then transport 3 in green. And there might be different reasons for that depending on the criteria of the application performance. So if we go back to the example here where we have, like, you know, we suddenly experience high latency towards 8.8.8.8 across our wide area network, we might see the traffic flows change like this. So here we've got, you know, different traffic flows taking their primary path. But if that 8.8.8.8 starts responding, you can see the sites at the bottom react to that and change the traffic flow accordingly. So with all that taken into equation, going back to the same thing, know your flows, knowing your traffic flows is often something that we see in large scale networks that, you know, there's no tools to understand what the traffic flows are. And it's other than doing a trace route from the site to the application, there's very little knowledge about how, you know, how the network actually operates. So yeah, that's another thing. You know, it's having tools and visibility to be able to understand that before you transform your wide area network is pretty important. So with local area networks, what we have in the picture here is a couple of examples of local area networks where all I really do is explain from the access layer. We have VLANs which go into access switches. The VLANs are then plumbed into a distribution layer switch of some kind, and anywhere you see a round dot on my diagrams, it normally illustrates where you see a round dot on my diagram, it illustrates a layer 3 interface. So you can see the dots on the diagram, the different colored dots on the diagrams are the default gateways for the different VLANs on the network. In the second picture, it's pretty much the same, but it's layer 3 routed access, where the green demarcation line moves down from the distribution switch to the access layer switch. This is a legacy network. Okay, a more modern network, for the local area network would look probably something like this. Let's see if my zooming in works this time. Yeah, so you can see that here we can introduce, and this is an example of like Cisco software defined access, where again, it's underlay overlay routing that we're talking about here. So you can see like the red dot is on the access layer switch, and that correlates to the VXLAN overlay 2 in the middle of the cloud. And if you think about that as like a completely segmented network that nothing other than red connected devices can access, and the same goes for the blue and then the gold sort of yellow colored cloud in the middle. So you could effectively have 3 different business units in your organization within the local area network and segment departments from each other. And even within those clouds, you can actually perform what we call micro segmentation, which means that if myself and Emma, who's my colleague on the call, if we were sitting next to each other and we were on the same subnet, so we were both on, I had an IP address of 10.10.10.10, and Emma had the IP address of 10.10.10.11. We can configure policies in SD-WAN, SD-LAN, Cisco software defined access, and other vendors to stop communication on a host level. The second example of an SDN, and just a couple more slides, I realise it's going to go over a couple of minutes, so apologies about that. But the other example that we have here of a software-defined LAN is a Fortinet software-defined LAN. So the idea here is that we have a Fortinet FortiGate firewall, a Fortinet FortiSwitch, and a Fortinet FortiAP. But these are all look as if they're one single device. So we can then roll out and enforce security policy across the whole stack in the site without having to go and individually configure security policies on every individual device. So this would be, pushed out with some of the, the tooling in Fortinet's case, and there's other vendors that we do work with, like Juniper, which is now actually part of HP. HP has HP Aruba and ClearPass. Cisco has Cisco ICE, and Fortinet has Fortinac, and some network access control technology within it. So these are just two examples because they're the most common vendors that we work with, but we do work with other vendors, and we're vendor agnostic from that perspective. So that kind of covers or scratches the surface on local area networks. The final sort of area that I wanted to cover was wireless networks, because I think that when we think about like replacing the wireless, and I'm not going to make air quotes, but I'm using air quotes when I say replacing the wireless, one of the key things that's overlooked is doing wireless surveys. So the way that access points are normally scoped out is people guess how many they need based on what they've got at the moment, and then they replace access points that have been in place for 10 years with brand new access points in exactly the same place, and then this is why you experience issues. So the reason for that is there's different standards with newer access points, and you might have 10 times the power, the radio power in a new access point versus an access point from 10 years ago. So if you don't do a survey and you put them in exactly the same place as less powerful access points have been, you're probably going to get suboptimal coverage, because the recommended overlap between access point signal is typically about 15 to 20%. If you put them in the same place and guess, you might have overlapping signal by 50 or 75%, and channel interference and all sorts of different things. So our recommendations are, if you're putting a new wireless network in, you should have a survey. That could even be a desk-based survey on a tool like you see on the screen, which again, we can provide desk-based surveys, but we would always advise that after a wireless network is implemented, then an on-site physical survey is done to ensure that the access points are placed in the correct place as per the coverage map, and also that the network is performing and there's no changes to the building since the survey was done initially. And then even after you install the Wi-Fi survey, it's recommended to do periodic surveys. Once you install the network, I'd say probably every 6 months or so is probably a reasonably acceptable timescale to do a survey. So just reiterating that changes to the environment can change the wireless performance. So channel interference, coverage due to access point outages, and then so if one access point drops off this network, then most of the solutions now try and sort it out themselves and provide secondary coverage. So if there's an access point that's not available, then you've still got the coverage to plug that gap. But other things, like if the office looks like it does in the floor plan that you see in front of you, and then the company decides to move all the desks around and put more glass panels up in the office to make another meeting space, all these types of things, in addition to even something like renting half of the office out to another organisation who put their own Wi-Fi in, that's another SSID that could potentially interfere with your own organisation's wireless performance. So to summarise, then, there's so much to cover, like enterprise networks, everything that I talked about. If you multiply this by, from a data center perspective, as a sort of loose number, by 10, what you've seen in the data center, if you multiply the per site stuff, so the LAN, the WAN, the Wi-Fi stuff, if you multiply that by several hundred, so the types of, we work with customers anything from you know, a couple of sites up to 400 sites in 65 countries to 1,100 sites, which are anything from offices to warehouses to shipping ports and terminals and containers all over the place, and these types of things. A real mixed bag of customers. It's going to be different requirements. So another thing that I would say is, like, I done this in my last place isn't really something that we would recommend either. These are some of the things that you know, we really recommend that are considered. So the key takeaways are, you know, regardless of if it's just like a single area, so like just LAN or just WAN or just data center, it's going to be complex. You know, you change one area and you're going to impact everything else. That is the likelihood of things. Understanding what devices you've actually got on the network, doing some kind of network discovery before you do a network transformation is recommended, and this can be done. Of course, there's commercial tools that are available to do that, but network automation is bringing a lot of capability in this space with scripting to do discoveries and things like that on the network. Application hosting locations, know your flows. I think I've done that to death on this on this webinar. So know what your traffic flows are, whether that's you know, with a tool and an analysis tool or something, but it's really important that you know that and you plan for your traffic flows in your new network. This is easier said than done, because if you've got like a business that you're reactive to as the IT department, and they say, we're buying a company next week and you need to start planning it, it's not always, and we need to exit by you know, in the next 3 months, then it's not always easy to say, oh well, we just need a bit of time for that. But it really does make a difference if you can get the time, and the time is a kind of subjective thing, but rushing anything through is only going to probably result in a messy migration and technical debt that you have to go and clean up later, that probably will never get cleaned up. We'll just do it like this to get the migration done. We'll fix it later. You kind of want to try and stay away from that. I mentioned network discovery tools and for performance monitoring and understanding segmentation. I never really covered it too much, just touched on it, but segmentation is used as we want segmentation on our network, but there's a massive difference between the example that I gave, like if you've got different business units segmentation, that's macro segmentation, versus host-based, client-based segmentation, where I don't want laptop 1 to talk to laptop 2, even though they're on the same LAN. Or if it's an OT environment, I don't want the light bulbs that are connected to the Wi-Fi to be able to communicate with the lift or the building management solution. So yeah, that segmentation, it's better to understand what your segmentation strategy is before you actually start doing segmentation in the middle of the project, because it's not that easy to, you know, kind of accommodate for. So yeah, that's OT, operational technology. This is more IoT machines and the light bulb to the lift chassis, or the building management solution, the HVAC systems, controllers and things like that control all these things. So that brings the end of the presentation. 9 minutes over, so noted for future webinars. How MNB can help? We are agnostic across different network technologies. So the vendors that you see on the screen, Cisco, Meraki, Fortinet, very strong, Palo Alto, HP, and we've also got like very good skills in open source network related tools like Netbox, Python, Ansible, and various other like monitoring tools that can sort of give that visibility. And the services that we offer are anything from scoping requirements, high and low level design, network discoveries, automation, network automation using scripting mechanisms, and delivering projects. We actually do network support as well, but it's not on this slide because it's not a full-blown sales pitch. Okay, so that concludes everything. The last few things that I want to say are thank you very much for taking the time out of your day to watch the webinar. If you have any follow-up questions, the details are on the screen. hello@mnbnetworks.tech. If you know any of us personally, reach out to us on LinkedIn, Emma or myself. Emma's consultant services manager and manages our engineers and consultants. Our website's there, and other than that, just close out by saying have a great day or evening wherever you are in the world. Thank you very much.